In a biology lab, we often put microorganisms onto petri dishes, and those petri dishes will contain agar. Agar we learned about as being a powdered seaweed that you can mix various solutes into. I want to test the effects of temperature on the yeast and whether it grows or not. And I also want to see if there's a difference between when I use one of these sterilized applicators to apply to the plate versus if I just use a little drip. So I'm going to saturate that cotton tip into my solution, making sure I'm getting it very well covered. And then when I open up my petri dish, I'm going to clamshell. Clamshell is when you open it up at an angle. I don't want to breathe on it. I don't want to contaminate it. So I just open it up slightly and I'm going to trace my zigzag line. And then I just close it again, not breathing on it, not touching it. So that might give me good data or not, but might as well try it. And then what I have are my 3 little target dots on the other side. I don't want to put a big amount of solution. So I'm going to also clamshell just at a little angle and then just put a wee little flea dot. One of my art teachers in elementary school always told us to use a flea dot of glue. And then I'm going to let that soak in. It's probably going to need to soak in for a good 5 minutes. I don't want to move it around now and get it all jumbled up. So we'll come back to see it go into the incubator. Now that our plates have soaked for about 5 minutes, I want to transfer these into our incubator. Our incubator has been set to body temperature, 37 degrees. So we can zoom in and show that little meter that's on there. Okay. And for me to open up the door, it's very easy. I stick my plate in and close it. My next one will go at room temperature. I don't want it to be in the sunshine, so I can leave it out on the counter. And then my third one is going to go into the laboratory refrigerator. So we're going to walk over to our fridge that says lab chemicals only. We're not going to store our lunches in here and get the diarrhea if you eat lab bacteria. And then I will put it in the fridge and close the door. Done.
All right, over here at this station, we're going to examine the experimental question, do yeast contain cells, right? Because that is one of the characteristics of things that are considered alive, right? And that's what we're testing. So what we're going to do here is we're just going to set up some microscope slides using a sample of yeast solution that we prepared prior. So now moving on to the scope. All right, whenever you're using a microscope, you always want to start by turning on the light source. That's a question kids always ask for some reason. There's a switch on the back. There's a red knob on the side to control the light intensity. And until you start to look at the object, you're not really going to know how much light you really need. It also depends on the amount of light in the room. I'm just going to start on high, and then as I'm looking at the object, I will adjust. So we should be able to see if there's cells there. And if there aren't, it's not alive. But if there are, maybe it is. So we'll take a close look. If I were to look here, I clearly see little oval-shaped cells. Some of them are larger than others. Some have a small little cell. It looks like it might be budding off the side. And maybe that's some further study for us. And that's it for the microscope.
Hi, maybe you don't recognize me from last week's video. I went 3.5 months without a haircut, so I really am Mr. Lucas, just so you know. They left the hardest part for me. Lots of stuff going on here. Actually, I can see exactly why they have this for me, because look at that right up there. They have Mr. Tall Guy. Grab down the plug. So let's go ahead and do that. We're going to use a balance here eventually. So I'm going to try to listen for the click. That's how you get that down there, right? So we're going to put that over there. And eventually, we're going to use this balance. So I'll go ahead and plug it in for now. Balance number 3 and plug number 3. Very important that those match up because we have to keep track of all of our equipment. For this part of the experiment, we're actually testing 2 things. Things that are alive typically obtain energy and they metabolize energy. We're going to test that with this part of the experiment. Also, they possibly respond to their environment. When there's a change in their environment, you may see a response out of that. So we're going to test both of those things. We have some baking soda here. We've got some good old table salt. I know you can't see this, but this is flour right there. And we've got some regular old table sugar. And then we've got the good old yeast that you saw Mrs. Harris put into the Petri dish earlier with her amazing technique and her snazzy new lab coat. So, okay, now we've got 5 test tubes right there. I'm going to actually put some labels that I pre-made onto these test tubes before I put anything in there. Some classes may be talking about this, some maybe not, but let's go ahead and talk about something first. Control groups. We all talked about that. There's actually 2 types of control groups. Most control groups are what we call a negative control, where we really basically give it nothing and we have a known result. So this test tube is going to be what I call my negative control. We'll talk about that in a minute. I bet you can't guess what the other kind of control group is. Positive control. You got it. Okay, so here we go. Positive control we're going to do for here. Okay. All right. Now, I have, for 3 of my chemicals, my baking soda, my salt, and my flour, I made 3 pieces of tape that say those 3 things. One that says BS. It really does mean baking soda. Okay, so there we go. There's my baking soda test tube. I have a piece of tape that says S for salt. And I have a piece of tape that says F for flour. Okay, yes, flour. Okay, there we go. Baking soda, salt, and flour. So I've got 3 experimental groups, and I've got 2 control groups this time, actually. That may be a little bit unusual, but I do have 2 control groups. There's another kind of control, experimental controls. Maybe you remember that from our class notes, class discussion. We want to try to keep as many things the same while we only vary one thing in this experiment. So one of the things we're going to try to keep the same is the amount of solution in our test tubes. Our negative control, I believe it's this one, yes, the minus C. Our negative control is only going to have yeast in there with nothing else. The goal of this experiment is to see if they metabolize energy. Well, we're not going to give this any energy whatsoever, so we don't expect anything to happen in here whatsoever. So I'll go ahead and show you the way we'll measure this out. It seems that 10 milliliters is approximately a good amount for this. So we're going to go ahead and use a graduated cylinder. You guys are used to those, I'm sure. And we're going to try to put 10 milliliters in that. So I'll get down eye level. That's kind of tough for me because my head's really usually way up there. So this is a little bit difficult. But I'll get down there at eye level. And we'll go ahead and try to fill this up to 10 milliliters. Again, this is the same solution Mrs. Harris used to put into the Petri dishes for her part of the experiment. Almost there. One more ought to do it. Oh, almost. Now remember, we're not at 10 milliliters until the meniscus, the bottom of that, which is really hard to see, the bottom of the curvature is above the 10. Plus there's some bubbles in there, so it's a little bit tough. So it might not be exact. I feel like that might be good there. I can see the top is a little bit above, but there's a bottom bubble below, right at the mark of the 10. So you can verify that for me. And then we're going to go ahead and put that in our minus C for our negative control, and this test tube is done. This is all we're going to put in here. Again, there's no energy in here whatsoever. I don't expect anything to happen whenever we set the rest of this up. Now, Ms. Schollenberger is going to, for the interest of time, go ahead and fill the rest of these with the appropriate amount of solution while I show you something else. Okay, so the other thing that's going to go in our test tubes are some solid chemicals. What we have is the aqueous solution of yeast, just yeast and water getting in there right now. Ms. Schollenberger is putting that in there for us. But for now, we're going to go put some solid chemicals in there. We have sugar, just as a reminder, we have sugar, flour, I'll move this, sugar, flour, salt, and baking soda. One of these is actually going to go into every other test tube because we want to know if it will metabolize energy in different environments. The only one we know for sure that yeast should be able to metabolize is table sugar. So this is the energy that we're going to give it. A lot of people might make a mistake and forget that. And, you know, if it doesn't produce anything, I say, well, I know why. You didn't give it any food. So we're going to make sure we give them all some food. So what I'm going to do is I'm going to turn this on. Whoops, wrong button. I'm going to use a fresh weighing boat for everything I do. It's calibrating now. 4, 3, 2, 1. It gives me a little countdown there. Okay. I'm going to put an empty one on there, and I'm going to actually hit the 0 button so that now it's measuring 0 grams. It should be.
Yeah, just hit
Okay. I'll try it again. Okay. 0.01 grams, that's fine. That's precise enough. That's precise enough. Yes, I agree. What we're going to do is we're going to decide on about 2 grams worth of all solid chemicals. That's a nice, standard, easy to remember measurement. So we're going to go ahead and try to add just a little bit of sugar at a time. That's about half of a gram. So I'll probably take about 4 times what I just did there. Once I get close, I want to be careful. Because I want to try to not overshoot it because I don't want to put stock solution back. Or I'm sorry, I don't want to put things out of the stock back into the stock if I don't have to. Well, I'll have to dump it if I do, basically. So we just keep going until we get to 2 grams. Ooh, so close. 0.03 grams. That's going to be tough to get. So close. Oh.
What?
It's kind of hovering there. You know what? I would say 2.06 is close enough because we're within 1/10 of a gram. I would say that's pretty close. So that's what I would do. I'll go ahead and show you one of the other treatments. One of the test tubes is only going to get this. That's our positive control. But some of the other treatments are going to get 2 grams of something else. Maybe we'll see a change in the yeast behavior if we throw some salt into there and make the water salty. So we're going to go ahead and try to do that. So let's aim for a total of 4 right now. Whoops, I want to use a different scopula. Here's the one for the salt. 4.1. We'll go ahead and say that within 1/10 of a gram should be fine for this lab. Okay. And then whenever we have our test tubes ready, we can just go ahead and put this inside. And then we'll go ahead and put the other ones together for you now.
So Mr. Lucas measured out all of our substances for us, and now I'm going to add them to the respective test tube. So my first one on my right-hand side is the negative control. So I am not adding anything additional to that one. Next, I have my positive control, which is my table sugar. And we have the 2 grams measured out in our boat here. Next, I have my flour. Next, we have the salt. Okay, and then my last one is my baking soda. We're trying to see if the organism will metabolize. And how we do that is we're going to put these balloons on top of the test tube. So when an organism metabolizes its food, it releases a gas. And if these metabolize, we're going to try to catch the gas in the balloon. So I'm going to try to get it on here, trying to squeeze out all of the air in the balloon first. It's kind of hard. There we go. I want to make sure it is sealed nice and tight around there. We have little rubber bands if we need them. And we're using a different colored balloon for each substance. Okay, they look like they're all sealed good. We're going to let them sit here and see what happens.
Hey everyone, Mr. Lucas here. It's the morning after our lab setup that we showed you. Going to check these results and see if we have anything exciting. Maybe this yeast is alive, maybe it's not. I don't know. What do you guys think? What do you guys think is going to happen? So Mrs. Harris isn't here this morning. She's working from home, so it's up to me. Oh my goodness, she left it up to me. She'll learn someday. Okay, whoops. Unlock the door. Head into the lab here. And let's take a look at what we have. Oh my, this looks really nice. Okay, I've got no one else. I can take the mask off. There's nobody else in the room here. This is some pretty good stuff, guys. Check this out. I'm gonna turn my camera around. Can I do that? I can't do that. All right. So some pretty different results. So there's Mr. Pingler. How you doing there, Mr. Pingler? Wow! That's pretty awesome, isn't it? Look at that. I'm so glad I taped those balloons shut because the air didn't leak out. Look at that. So here's our negative control. If you remember what that is, we've got a deflated balloon there. The big yellow ones are positive control, if you remember what that is. And then our three treatment groups. We've got the one with flour, there's the white balloon. The one with sugar there, I'll hold this up. It's pretty deflated, but there's a tiny bit if I squeeze it.
Not sugar. What was that?
Oh, that's right, it's not sugar, it's salt. No, they both start with S. You're right, there's flour, sugar, and then baking soda. But remember, they all have sugar in there as well because we had to give them some food. Another set of results to look at. How about these plates that Mrs. Harris plated? Here's the one at room temperature. Check that out. Look, we got a glare there. How about that? There we go. Look at that. So there's her streak and her dots. These are the ones at room temperature. Now I'll check the one in the incubator as well. This is the one at 37-degree body temperature. There's this one. There's a little bit of condensation on the lid, so let me just kind of rotate it for you there real quickly, show you. There's what it looks like. Let me put them next to each other.
Here, Mr. Lucas, I'll get the one from the fridge.
Oh, okay. You know what? So let's see if we have any growth. I put them in order of cold to warm. I'm going to lift the lids off very briefly here so we can see a little better. But this is what it looks like from cold to warm. Let me move them a little closer to each other. Right there, look at that. So the cold one in the fridge, the one at room temperature, and the one in the 37-degree Celsius incubator, which is body temperature.